Today, we are diving into important piece in Web3 and DeFi. It's oracles. They might not be as flashy as NFTs or DeFi itself, but without oracles, the DeFi wouldn't exist as we know it today. Blockchains are incredible for storing and verifying data in a secure and decentralized way. But there is one big limitation. Blockchains lack internet connection. They can't access data from the outside world on their own. That's where oracles come in. Oracles are like bridges between the blockchain and the real world. They bring in external data that smart contracts can use to make decisions. For example, if a DeFi platform wants to offer trading or lending based on real-world prices, it needs oracles to fetch accurate and up-to-date information, because there is no other way to get that information on-chain. Imagine you're using a DeFi app to trade crypto. To make sure your trade is fair, the app needs to know the current market price of the token you're trading. Oracles provide that data in real time. Without oracles, smart contracts will be like ships lost at sea with no GPS, because they have no way of knowing what's happening outside of the blockchain. If you remember how decentralized exchanges work, which we covered in the previous video, they don't need oracles. The AMM mechanism with liquidity pools and constant product formula, the price is always known. This is interesting because this allows decentralized exchanges to act like oracles in terms of getting the price of pair of tokens. But their price only reflects the liquidity pool that they own, so they are not the most reliable place to get the prices. Back to oracles. Oracles aren't just about price feeds. They can provide any kind of data, like weather data for blockchain-based insurance, sports scores for prediction markets, and most importantly, random numbers. Blockchains don't have the technical capability to generate random numbers because they operate as deterministic systems. This means that every node in the network must arrive at the same result for a given set of inputs to maintain consensus. Generating random numbers is totally against this principle, and it will break this deterministic nature. So, to ensure fairness and transparency in use cases like gaming and lottery, oracles step in to provide random numbers. They use methods like verifiable random functions, VRFs. A VRF is a cryptographic method that generates random numbers along with a proof. And this proof makes sure that the number generated is fair. This proof can be verified on-chain by smart contracts, ensuring randomness is both secure and transparent. This makes oracles essential for DApps that rely on randomness. Now that we know what oracles do, let's break down how they work step by step. Imagine you're using a DeFi platform that needs real-world data, like the current price of ETH, to execute a smart contract. Here's what happens behind the scenes. It all starts when the user or a smart contract submits a data request. For example, what is the current price of ETH in USD? This request is sent to the blockchain and logged as an event. Along with the request, the smart contract also specifies the address of the requesting smart contract and the name of the callback function that should be triggered when the data is ready. These details are essential for oracles to know so they can send the data when they fetch it. The blockchain passes this request to an on-chain oracle smart contract. This contract acts as a middleman and coordinates the communication between the blockchain and the external data sources. The oracle service listens for these requests. Once it detects the request, it fetches the required data from external sources. For instance, it might query several crypto exchanges to get the latest price of ETH. Step 4. If the oracle is decentralized, it aggregates data from multiple sources to ensure accuracy, or use medium values to reduce the chance of manipulation. Step 5. After validating the data, the oracle service sends it back to the blockchain by calling the oracle contract and passing the data as a response. The oracle contract then calls the predefined callback function. This push mechanism makes sure that the smart contract receives the data it needs. That's a basic overview of how oracles work. Oracle projects are continuously evolving to make their infrastructure better, cheaper, and more secure. Since individuals and smart contracts cannot access real-world data by themselves, they rely on oracles like Chainlink, Pyth, or Switchboard. These oracles typically charge a provider fee for the service they provide, which helps maintain and secure their decentralized networks. However, the oracles are not without risks. Since oracles often fetch data from third-party services like APIs, there is a chance that the retrieved data could be false or manipulated. If an attacker gains control over these sources, they could feed corrupted data into smart contracts. This could lead to incorrect outcomes, like failed transactions or unfair trades. To prevent this, oracles must use trusted and multiple sources to retrieve its data. Now you know how oracles bring real-world data to blockchains, and why they are key for making decentralized systems, like DeFi, truly functional. But remember, while oracles are incredibly useful, there are risks involved, especially when it comes to data manipulation. Next up, we will be diving into bridges, what they are, how they work, and why they are a key part of DeFi and blockchain interoperability. That's it for today. See you around and take care.